Welcome to the Platform Engineering Playbook podcast, where everything you hear is built, reviewed, and improved by AI, by me, and by you, the listener. This show keeps me, and hopefully you, up to speed on the latest in platform engineering, SRE, DevOps, and production engineering. It's a living experiment in how AI can help us track, explain, and discuss the fast-moving world of infrastructure. Every episode is open source. If you've got something to add, correct, or challenge, head to platform-engineering-playbook.com. You'll find all the content and a link to the GitHub repo. Open a pull request, join the conversation, and make the playbook smarter. Let's get into it.
Welcome to part 3 of our 4-part AWS reInvent 2025 series. In episode 49, we covered agentic AI and frontier agents. Episode 50 dove into Graviton 5, Trainium 3, and Lambda durable functions. Today, we're covering what I think is the most consequential announcement for platform engineers: how AWS is transforming EKS from a container orchestrator into a full AI infrastructure platform. But first, let's check what else is happening in platform engineering.
And there's actually some urgent news today. cert-manager version 1.19.2 just dropped, and it's patching 2 CVEs in the Go standard library, CVE 2025-61727 and CVE 2025-61729. If you're running Trivy scans, these will get flagged on your next run.
This is a patch now situation, not a next sprint situation. The good news is it's a straightforward version bump with no breaking changes. And if you're still on the 1.18 branch, version 1.18.4 backports the same fixes.
In other news, Canonical just extended Kubernetes long-term support to 15 years. 15 years! They're doing this through Ubuntu Pro plus a legacy add-on, and they're clearly targeting enterprises that need mainframe-level support cycles.
That's fascinating positioning. Meanwhile, OpenTofu 1.11 dropped with a feature I've been waiting for: ephemeral resources. You can now handle secrets without them persisting to state files. They also added an enabled meta argument to replace those awkward count conditionals we've all written.
Cloudflare published a detailed post about how they manage hundreds of internal accounts with infrastructure as code. They're implementing shift-left security to prevent misconfigurations that could propagate globally in seconds. Worth reading if you're running IAC at scale.
And one more quick hit, there's a Go proposal gaining traction for runtime secret mode. It would protect sensitive values from memory dumps and debugging, important for anyone handling credentials in Go services.
All right, let's dive into reInvent. Jordan, when you say EKS is becoming an AI infrastructure platform, what does that actually mean?
It means AWS made 4 massive announcements that fundamentally change what EKS can do. First, EKS Ultrascale, which supports 100,000 nodes in a single cluster. Second, EKS Capabilities, which brings managed Argo CD, ACK, and KRO. Third, the EKS MCP server for natural language cluster management. And fourth, provisioned control plane with guaranteed performance tiers.
Let's start with Ultrascale because the numbers are staggering. 100,000 nodes per cluster. To put that in context, Google Kubernetes Engine maxes out at 15,000 nodes per standard cluster. Azure Kubernetes Service caps at 5,000.
Right. AWS now has a 6 to 20x advantage in cluster scale. But the real number that matters isn't nodes, it's accelerators. 100,000 nodes means you can run up to 1.6 million AWS Trainium accelerators in a single cluster, or 800,000 NVIDIA GPUs.
That's the scale you need for training trillion parameter models. And these AI workloads fundamentally can't be distributed across multiple clusters easily. The training job needs all accelerators available within one logical cluster.
Here's where it gets technically interesting. The bottleneck at scale has always been etcd. The Kubernetes control plane stores all cluster state in etcd, and etcd uses Raft consensus for replication. Raft works great at normal scale, but it becomes the limiting factor when you're trying to coordinate 100,000 nodes.
So what did AWS do?
They completely overhauled etcd. They replaced the Raft-based consensus backend with something they call Journal. This is an internal component AWS has been building for over a decade. It provides ultra-fast, ordered data replication with multi-availability zone durability.
So they essentially swapped out the replication engine under etcd.
Exactly. And they went further. They moved etcd's entire backend database to in-memory storage using tmpfs. This gives order of magnitude performance wins, higher read-write throughput, predictable latencies, faster maintenance operations. They also doubled the maximum database size to 20 gigabytes.
What about pod scheduling at that scale? The scheduler becomes a bottleneck too.
AWS optimized the scheduler plugins and node filtering parameters specifically for large-scale workloads. The result? They achieved 500 pods per second scheduling throughput even at 100,000 node scale.
That's impressive. Are there real customers running at this scale?
Yes, Anthropic is using EKS Ultrascale to train Claude. They reported that their end-user latency KPIs improved from an average of 35% to consistently above 90%. Amazon is also using it for training Nova models.
Let's move to EKS capabilities because this affects more teams directly. What problem is this solving?
Platform teams have been running Argo CD for GitOps and ACK for managing AWS resources from Kubernetes. But maintaining these systems is real work. You need to patch them, upgrade them, ensure compatibility, handle scaling. EKS capabilities makes all of that AWS's problem.
So AWS is now managing Argo CD for you?
Yes, and it's not just running in your cluster. These capabilities actually run in AWS service-owned accounts that are fully abstracted from you. AWS handles infrastructure scaling, patching, updates, and compatibility analysis.
Let's break down the three capabilities. First is Argo CD.
Argo CD is the most popular GitOps tool for Kubernetes. The 2024 CNCF survey showed 45% of Kubernetes users are running Argo CD in production or planning to. With EKS capabilities, you get a fully managed Argo CD instance that can deploy applications across multiple clusters. Git becomes your source of truth, and Argo automatically remediates drift.
Second is ACK, AWS Controllers for Kubernetes.
ACK lets you manage AWS resources using Kubernetes custom resource definitions. The managed version provides over 200 CRDs for more than 50 AWS services. You can create S3 buckets, RDS databases, IAM roles, all from YAML. No need to install or maintain controllers yourself.
And third is KRO, Kube Resource Orchestrator.
KRO is about abstraction. Platform teams can create reusable resource bundles that hide complexity. Developers consume these abstractions without needing to understand the underlying details. It's how you build your internal developer platform on Kubernetes.
What does the multi-cluster architecture look like?
You run all three capabilities in a centrally managed cluster. Argo CD on that management cluster deploys applications to workload clusters across different regions or accounts. ACK provisions AWS resources for all clusters. KRO creates portable platform abstractions that work everywhere. It's a clean separation of concerns.
How does pricing work?
Per capability, per hour billing with no upfront commitments. You're charged for each capability resource for each hour it's active. There are also additional charges for the specific Kubernetes resources managed by the capabilities.
Now let's talk about the EKS MCP server, because this feels like a glimpse of the future. What is MCP?
MCP stands for Model Context Protocol. It's an open-source standard that gives AI models secure access to external tools and data sources. Think of it as a standardized interface that enriches AI applications with real-time contextual knowledge.
And AWS built an MCP server for EKS.
Yes, the EKS MCP server lets you manage Kubernetes clusters using natural language instead of kube control. You can say, show me all pods not in running state, and it just works. You can say, create a new EKS cluster named demo cluster with VPC and auto mode, and it does it.
No kube control, no kube config.
Exactly. You can get logs, check deployments, create clusters, all through conversation. The server translates natural language into AWS and Kubernetes API calls behind the scenes.
What about security and enterprise requirements?
The MCP server is hosted in AWS Cloud, so there's no local installation or maintenance. You get automatic updates, patching, AWS IAM integration for security, and CloudTrail integration for audit logging. Plus, it draws on a knowledge base built from AWS's operational experience managing millions of Kubernetes clusters.
What AI tools does it integrate with?
It works with Kuro, which is AWS's IDE, and CLI, also Cursor, Klein, and you can use it with Amazon Q Developer. Or you can build your own agents that interface with EKS clusters through the MCP server.
This changes who can operate Kubernetes clusters.
That's the key insight. AWS was one of the first managed Kubernetes providers to implement MCP. They're betting that conversational AI turns multi-step manual tasks into simple requests. The barrier to Kubernetes operations just dropped significantly.
Let's cover provisioned control plane before we move to cloud operations. What problem does this solve?
Standard EKS control planes have variable performance. Under burst loads, you can get unpredictable behavior. Enterprises need guaranteed SLAs, especially for production workloads. Provisioned control plane lets you pre-allocate control plane capacity with well-defined performance characteristics.
How do the tiers work?
They use t-shirt sizing: XL, 2XL, and 4XL. Each tier defines capacity through 3 attributes. First, API request concurrency, which is how many requests the API server can handle simultaneously. Second, pod scheduling rate in pods per second. Third, cluster database size for etcd.
What can the 4XL tier do?
4XL supports up to 6,800 concurrent API requests and 400 pods scheduled per second. In stress testing, AWS showed it can support 40,000 nodes in 640,000 pods. That's an 8x improvement over standard control planes.
What does it cost?
XL starts at $1.65 per hour. 4XL is $6.90 per hour. That's in addition to standard or extended support hourly charges. You can switch tiers as workloads change or revert to standard control plane during quieter periods.
Now let's shift to cloud operations, because AWS made equally significant announcements there, starting with CloudWatch.
CloudWatch now has comprehensive observability for generative AI applications and agents. You get built-in insights into latency, token usage, and errors across your AI stack. No custom instrumentation required.
What frameworks does it support?
It works with Amazon Bedrock Agent Core natively, but it's also compatible with open-source agentic frameworks like LangChain, LangGraph, and Crew AI. You can monitor model invocations, trace agent workflows end-to-end, and identify performance bottlenecks.
This is critical as more teams deploy AI agents.
Exactly. Agent observability has been a gap. You deploy an agent, and when something goes wrong, you're debugging in the dark. Now you have proper tracing and metrics out of the box.
What about the DevOps agent?
The AWS DevOps agent is in preview, and it's essentially an autonomous on-call engineer. It analyzes data across CloudWatch, GitHub, ServiceNow, and other tools to identify root causes and coordinate incident response.
Has anyone measured the impact?
The Kindle team reported 80% time savings using CloudWatch investigations, which is the underlying technology. The DevOps agent goes further by acting proactively. It correlates telemetry, identifies root causes, and reduces operational burdens so teams can focus on higher value work.
CloudWatch also got MCP servers.
Yes, the MCP servers for CloudWatch bridge AI assistance to your observability data. They provide standardized access to metrics, logs, alarms, traces, and service health data. You can build autonomous operational workflows and integrate CloudWatch with AI-powered development tools.
What about data management?
CloudWatch introduced a unified data store for operations, security, and compliance data. It automates collection from AWS and third-party sources like CrowdStrike, Microsoft Office 365, and SentinelOne. Everything gets stored in S3 tables with OSCF and Apache Iceberg support.
That simplifies the log aggregation problem.
Significantly. Automatic normalization across sources, native analytics integration, built-in support for industry standard formats, and the first copy of centralized logs incurs no additional ingestion charges. It's actually cost-efficient for multi-account log management.
What else is new in observability?
Application Signals now has a GitHub action that provides observability insights during pull requests and CI/CD pipelines. Developers can identify performance regressions without leaving their development environment. There's also auto discovery that visualizes application topology without requiring instrumentation.
And database insights?
CloudWatch Database Insights now supports cross-account and cross-region monitoring. You can get centralized visibility into database performance across your entire AWS organization. It supports RDS, Aurora, and DynamoDB from a single monitoring account.
Let's wrap up with what all this means for platform engineers.
There are 4 big takeaways. First, scale is no longer a constraint. 100,000 nodes opens new architecture patterns that simply weren't possible before.
Second,
GitOps becomes turnkey. EKS capabilities eliminates the maintenance burden of running Argo CD and ACK. That's real operational toil that goes away.
third,
Natural language ops is real. The MCP server changes who can operate clusters. We're moving from kubectl mastery to conversational cluster management.
and fourth,
Observability goes proactive. DevOps agent as your first line of defense, Gen AI tracing out of the box, unified data management. The operations experience is fundamentally changing.
What's the overall pattern here?
EKS is evolving from a container orchestration service into a fully managed AI cloud platform. AWS is betting that Kubernetes will anchor the next decade of AI infrastructure. Every announcement we covered today focuses on AI workload enablement.
Next episode, we're wrapping up our reInvent coverage with Part 4, Data and AI Services, S3 Tables, Zero ETL, and how AWS is rethinking the data stack for AI workloads.
The infrastructure announcements we covered today set the foundation. For platform engineers, the question isn't whether to adopt these capabilities, it's how fast you can integrate them into your platform strategy. Because the teams that master AI infrastructure will define the next era of software delivery.
That's it for this episode of the Platform Engineering Playbook podcast. Every topic, transcript, and summary you just heard lives out in the open at platform-engineering-playbook.com, where anyone can suggest updates or add insights through GitHub. If you've got thoughts, fixes, or new ideas, open a PR. And if you enjoyed the episode, rate us on your favorite podcast platform. We're always shooting for 5 stars. While you're there, give the project a star on GitHub. It helps others find and contribute to the Platform Engineering Playbook. This podcast is generated by AI, reviewed by AI, me and you, a community of engineers keeping our craft sharp. Thanks for listening, and see you next time inside the Platform Engineering Playbook.